In this problem, we examine the continuity of a function at a point. We need to determine the value for k that will make the function continuous at the point c equal to 4. For the function to be continuous at a value c, we need the limit as x approaches c from the left of our function to be equal to the limit as x approaches c from the right, and that has to equal the value of the function at c. So in this case, we want the limit as x approaches 4 from the left of f of x. Now we have a piecewise defined function, so we need to check the values that we're going to be using in our limit. Since we're coming from the left, we're going to be using values for x that are less than 4, which means we need to use the first piece in our piecewise defined function. So the limit as x approaches 4 from the left of f of x will be the limit as x approaches 4 from the left of x squared minus 9 over x plus 3. Use our quotient rule. Write this as the limit as x approaches 4 from the left of x squared minus 9 divided by the limit as x approaches 4 from the left of x plus 3. In the numerator, we're taking the limit of a polynomial and plug in our value for c. We get 4 squared minus 9. And in the denominator, we again are taking the limit of a polynomial. We'll plug in our value for c, get 4 plus 3. So we'll have 16 minus 9, which is equal to 7, over 4 plus 3, which is 7, and 7 over 7 is equal to 1. Next, we'll look at the limit as x approaches 4 from the right. Here we're using values for x that are greater than 4, which means we need to use a second piece in our piecewise defined function. So we'll have the limit as x approaches 4 from the right of kx plus 5. This is a polynomial, so we'll just plug in our value for c. We'll get 4k plus 5 as the limit. If we evaluate our function, we want to find f of 4. Since x is equal to 4, we look at our definition. We see we need to use the first piece. F of 4 is 4 squared minus 9 over 4 plus 3, which is equal to 1. In order for our function to be continuous at 4, we need to have 4k plus 5 equal to 1, and we just solve this for k. So give us 4k is equal to negative 4, or k is equal to negative 1. So the value of k that makes the function continuous at c equal to 4 is negative 1.